Hello and welcome to my first e-video. Today's lesson is going to be on 3.2, the Axioms of Equality. Yesterday's lesson focused on the givens and what you can conclude from the givens. Today we're going to look at the Axioms of Equality so that when we construct our proofs in the future, we'll be able to use them to help justify our reasons. Now, a word about this video. There will be occasional points where I will stop the video and ask you to answer some questions. Those questions will not be graded for correctness, but they're a chance for me to check your understanding of the video as we go along. So please answer them appropriately. So let's get right to the lesson. So you should have had the note sheet given to you from your teacher. If not, please pause the video to make sure your teacher can give you the lesson for today. So geometry is all about figures and how they relate to each other. And there are certain axioms, if you remember back to lesson 1.8, we talked about axioms a little bit. Certain axioms are about properties of equality. And specifically with geometry, we look at the measurements in space. And since we deal with segments and angles, we're going to be focusing on length and angle measures. So let's first look at this exercise 1. So in each diagram here, we want to make a statement about how the whole measure relates to the individual parts of the measurement. So for part A, we are given AFT, segment AFT. Now how the whole relates to the part, well, the whole is AT. That measurement is going to be related to the parts by adding the parts together. AT is equal to AF plus FT. That is using the axiom that the whole is the sum of its parts. And that's the reason we would list to write that statement. For letter B, we have angles. The whole angle is NRS. So we said that the measure of angle NRS is equal to the sum of its parts. The measure of angle NRK plus the measure of angle KRS. And that's a statement we can conclude from this diagram with the axiom, the whole is the sum of its parts. So again, as we go through, pause the video and write down anything you need to before moving on to the next part. Now these axioms should seem obvious to you, and that's a no-brainer because they should make sense. These are essentially true statements that can't be proven or do not need proven, okay? And they should be intuitive. Let's look at number 2 and look at another axiom. We're looking at exercise 2 focuses on the addition axiom, okay, and how it's applied. So in this case, we are given segments CE and FE have equal measures, and segments EB and ED have equal measures. And we're asked to prove that segment CB and FD have equal measures. Now this first part, letter A, is asking you to look at some numerical values just to test and play around with it a little bit. And it's going to lead us into what we're going to do down below for our reasons for this proof. So let's first make a test case so we can understand what's given. So if we are given that CE is equal to FE, they're going to have the same measures. So I'm going to say, let's say they're both 2 units. And we're also given that EB is equal to ED, so I'm going to label those with certain measures. Now looking at the measures we have chosen, we want to prove that CB is equal to FD, or in other words, the whole of the first segment is equal to the whole of the second segment. And notice that 2 plus 7, that is CB, that is equal to 2 plus 7, which is equal to FD. And that's essentially what we're going to be doing in part B. This is your first exposure to a 2-column proof where essentially you list a bunch of mathematical statements and they have to go in a specific order. You always have to start at the top, and from those starting statements we make conclusions, and each line is based upon previous statements above. And corresponding with each statement is going to be a reason why you can write that statement, why you can conclude that statement is true. And proofs will always follow some kind of logical succession. Okay? Each step, as I mentioned, follows from something above it. So line 2 could follow from line 1. Line 3 could follow from line 1, or it could follow from line 2. So let's look at this proof. The first line here in our proof is CE is equal to FE and EB is equal to ED. Now the question we always ask yourself in these proofs is why we can write that statement. Now if you look back up to the original problem, up here, we were told that those were true. Those were our givens. So for our reason, we're going to write given. Those statements are given to us, and that's why we know that they're true. The next line, we have CE plus EB is equal to FE plus ED. Now you have to start thinking about where this line comes from. But if we look at it carefully, let's look at CE is equal to FE. That's one of our givens. EB is equal to ED. Aha, this is where we use the addition axiom. Notice it says if equals are added to equals, then the sums are equal. And that's what's happening here. So we have the addition axiom. Because what we did is we added EB and ED, which are equal, to CE and FE. Those are equal. So equals added to equals are equal. For line 3, we say that CB is equal to FD. And if we compare that to line 2, notice that CE and EB, well, those are the two parts of the whole. So as looked in the axiom in number 1, those must be equal. So what we're going to write there is that the whole is the sum of its parts. Pause the video now and write down anything you need before we move on to exercise 3. Okay, so exercise 3, a natural next stepping stone is to look at the subtraction axiom. The subtraction axiom. It's very similar to the addition one, except you're dealing with subtraction. If equals are subtracted from equals, then the differences are equal. So in this problem, in this exercise, we are given angle BAD and angle CAE have equal measures. And we're asked to prove that BAC and DAE are equal in measure as well. So we are given this angle, BAD, and CAE are equal. And given that information, we're asked to prove that BAC and DAE are equal. Now the first question is asking you, why would this have to be true? Pause the video now and write down anything answer the question on the right side. Okay, hopefully you saw why they have to be equal. Now if you let's assume that BAD is a certain degree measure. So let's say BAD is, let's say 40 degrees. Okay, it might be a little more, it might be a little less, who knows? You know, this isn't necessary to scale. And let's say that angle CAE is 40 degrees. Well, they both share angle CAD. So why do those end up having to be equal? If you take away CAD from both those angles, you're left with the two angles we're trying to prove are equal. The reason is because angle BAD and angle CAE both contain angle CAD. Okay. You can subtract angle CAE. So let's look at the proof. Okay, let's look at the formal proof for this. So for line 1, we are given that BAD and CAE are equal. And you may notice typically the first line is a given statement. So that's what we're given. That the measure of angle BAD and CAE are equal. Now let's look at the next line, see how it relates to the lines above it. BAC and CAD, well, BAC and CAD, well that's that first axiom again. The whole is the sum of its parts. The whole angle, which was BAD, can be broken up into BAC plus CAD. The whole angle CAE can be broken up into CAD plus DAE. The whole is equal to the sum of its parts. Now, as mentioned in part A, what we're going to have to do is we're going to subtract off the shared angle. So what we did is in line 3, we said that measure of angle CAD is equal to the measure of angle CAD. Well, that's kind of like a duh statement, right? It's always going to be congruent to itself. So they're going to have equal measures. So what we can write for a reason here is that an angle has the same measure as itself. It's necessary to put that there because in order to subtract off that from both angles, we need to say that they're equal. Okay? And notice line 2, both sides of the equation have angle CAD. So if you subtract those left, if you subtract those from both sides, you're left with BAC and DAE. So this is where the subtraction axiom comes into play. Okay, pause the video now before moving on to the last example. All right, this last axiom is the substitution axiom. And that says that quantities equal to each other or to the same quantity, they may be substituted in for each other. So, in this example, we are given that lines M and N intersect to form angles 1, 2, and 3. We want to prove that angle 1 has the same measure as angle 3. Or another way of saying that is that vertical angles are equal. That's what we want to do. Now notice this case I did not have any filled out statements, so we're going to fill out both the statements and the reasons for this proof. Let's start off with the given. Lines M and N intersect to form angles 1, 2, and 3. So I'm going to write that in my statement for line 1. And my corresponding reason is going to be given. Now just a note, in the last examples, we already had the lines numbered for us, but just make sure that whenever you're doing a two-column proof, you have to number each statement and each corresponding reason. It helps to make the proof look a little bit easier to read and helps keep it organized. You need to have each line labeled. Alright, so those are given. Lines M and N intersect to form angle 1, 2, and 3. Now our eventual goal is to show that angle 1 is equal to angle 3 in measure. Now, we got to think about facts we know from the given. We have lines M and line N. From those facts, we can say that 1 and 2 add to 180. We can also say that 2 and 3 add to 180, because all the angles on a line add to 180 degrees. So that's going to be what we'll put for line 2 and line 3. The measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And we have to write a reason, and you can simply state the reason why that's true. All angles at a point on a line add to 180 degrees. Now, because this is you're going to use the same reason for 2 and 3 adding to 180, we can actually include that on line 2. So if I put a comma after 1 and 2 add to 180, I can say the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now, I can put that on that line because it's for the exact same reason. And that's allowable to do. All right, now, angle 1 and angle 2 add to 180. Angle 2 and angle 3 add to 180. Well, if I take these two angles, add it together, since it's equal to 180, and substitute it into the 180 in the first equation, that's what I mean by the substitution axiom. So I can write the line, measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus measure of angle 3. Because I took that second equation, the angle 2 and angle 3 added together, and substituted it into 180 degrees in the first equation. So the reason for line 3, is the substitution axiom. Now, looking at our equation, we might see what the last step is going to be. Both sides of the equation have angle 2 in it. So if I subtract those from both sides, I'm left with the statement the measure of angle 1 is equal to the measure of angle 3. And as you could probably guess it, this is going to be the subtraction axiom. And there's your first proof, writing out both statements and reasons. Now, eventually the triangle proofs we're going to be doing are going to be a little bit easier because we're not going to have to deal with all these axioms as much, but there are some proofs where you do have to use these addition, subtraction, substitution, the whole is equal to the sum of its parts. All those axioms are going to be necessary. Okay, and these are some examples of when those are necessary. So pause the video before moving on to the assignments. So for the remainder of class today, I want you to focus on the assignments 3.2. So now that you finished the video, please raise your hand and ask the substitute to come over and give you the assignment. I will reserve some time at the beginning of class tomorrow to answer questions you may have. I may or may not have an opener prepared, so be prepared for that. And I want you to make sure you bring your homework completed. Even if you have questions, I want to see that you at least tried the homework. There are some challenging questions on the homework. You may not be sure which choice is going to be correct, especially on the first page. But see if you can reason it out the best you can. Talk about it with your partner, and then we'll go over it in class tomorrow. I want to thank you for watching this video, and I hope you enjoyed it. And I will see you tomorrow in class.